Hi, in this video we're going to see a concept introduction to BGP. First of all, a brief review of what we already know about BGP. BGP is basically a routing protocol which allows to establish the path packets will follow between different autonomous systems, and it's based on advertising all possible paths and applying rules which are called policies. Now a disclaimer, we're talking about concept BGP here. It's a simplification. In this video, we will assume the autonomous systems at the network core only have one router, while in the real world, they have many routers and an intra-domain routing system. This could be an example network. In this case, we have 5 end autonomous systems, which are numbered from 1 to 5 and have circle shapes. And we have 7 network core autonomous systems, which are named from A to G, and are shaped as clouds. Now, regarding the interfaces, we will assume each interface is named after the autonomous system ID and is numbered in clockwise order, as you can see in the figures. Regarding advertisements, each autonomous system will send advertisements with 3 elements. First element will be destination network or prefix. Second element would be the path to destination, which will be always specified in reverse order, that is with the end autonomous system at the beginning. And the third element will finally be the output interface. Now we are going to see the policies that will be applied in BGP for this video. Remember, this is a simplification. The end autonomous systems will have 4 policies, which are named as E1 to E4, okay? The first of them is that each end autonomous system will send to their neighboring autonomous system, the ones it is directly connected to, the information about the network reachable within the autonomous system. The second, that if an end autonomous system receives info about another one, it will not advertise it. The third one, if it receives several paths to a given end autonomous system, it will always keep the shorter. And the fourth one, when choosing between equal length paths, it will keep the lowest in lexicographic order. That means the lowest in alphabetic or numerical order. Now the policies of the network core autonomous systems, which will be numbered as C1 to C3. The first, that they will only advertise paths having a neighboring end autonomous system as the source of or the destination. The second, that if it receives several paths to a given end autonomous systems, it will keep the shorter. And the third one, that when choosing between equal length paths, it will always keep the lowest in lexicographic order. Okay, let's see an example. In particular, a very simple example with only 2 end autonomous systems and 4 network core autonomous systems. First of all, autonomous system 1 will advertise to A and to B. Both advertisements will carry the same network prefix and the corresponding path and output interface. Now, A and B have to advertise these networks too. So first, autonomous system A will advertise it to B, but B will reject it because given rule C2, if it receives several paths to a given autonomous system, it will keep the shorter, which in this case is the one it already had. A will also advertise to D and to C. Now B, it's going to advertise to A, but A will reject this advertisement because, again, because of rule C2, if it receives several paths to a given autonomous system, it will keep the shorter. Now B will advertise to D, and D will also reject this advertisement because when choosing between equal length paths, it will keep the lowest in lexicographic order, which is the one it already had. Now D will advertise to 2, and also C will advertise to 2, but 2 in this case will replace previous path because when choosing between equal length path, it should keep the lowest in lexicographic order, which in this case is the last one it has received. D has nothing to advertise to C because per rule C1, it only should advertise paths having a neighboring AS as a source or as a destination. And C will not advertise anything to D because it only should advertise paths having a neighboring AS as a source or as a destination. Well, the protocol would go on, and after the end autonomous system to advertise, the result would be more or less what you can see in the figure. Okay, remember that this is only an example. In the real world, the core autonomous system do not have a single router, and there should be an internal routing system, which normally is what we call the hot potato routing, which is basically trying to leave the autonomous system as soon as possible. Also, each border road would store its own information and apply the policies, and each router in the autonomous system would choose its own path. Here you can see an example of what would be an autonomous system in the real world. As you can see, it has a lot of routers inside, and it may have several paths to a given destination prefix. So, for instance, if we receive a packet intended towards the 1300 path, and we receive it through the upper left router, it would go by hot potato routing towards the bottom left router, while if we receive it via the middle right router, it would go by the bottom right interface. Again, because of which hot potato routing. Remember, we try to leave the AS as soon as possible.